I'm going to pass you on to our first speaker. Hopefully this will work. So I've got Michael Wicks as our first presenter, and I've got a little bit of a spiel for Michael. Hope he doesn't mind. Best hair in stormwater. So Michael is a civil engineer with 15 years' experience. He doesn't look a day out of 21. He's technical director of Stormwater 360 Australia, directing their product development, product evaluation and regulatory service departments. He has designed, constructed, implemented and monitored numerous stormwater quality treatment facilities throughout the east coast of Australia. Please welcome to the lectern Michael Wicks. Thank you.
Thank you, Mr. President. Okay, so today's topic about squid devices. And I suppose I looked at the brief and said, well, okay, what is the appropriateness of the techniques currently available? We have no test procedures for squids in Australia, and that causes a lot of issues. Remember, manufacturers do have commercial pressures to put their devices in the ground, and we have to get approvals through regulators. But the data that sometimes is used is piecemeal or lab data, and that puts pressure on regulators to either misapprove or not approve technologies, so we don't see the uptake. And that also delays the development process as well. So it's quite a large issue revolving around the manufactured devices. So there's no testing protocol, but what is the guidance? Currently in Queensland we have the Water by Design Music Modelling Guidelines. Now, every council that I've dealt with in Queensland uses this as an assessment method for stormwater treatment devices. We're also seeing this document actually used in New South Wales. The New South Wales SCA and the New South Wales CMA Metro as well have their guidelines based on the gross pollutant sections of this document. And it provides a fair pathway for both parties. Hey, there's an assessment criteria that the regulators can assess the manufacturer's claims against, and there's some rough guidance on what the manufacturers have to achieve. The key points or key sections in that is 4.8 and 4.14 of these guidelines. And there's about 7 different points. We're just going to run through a couple today, just the important ones. Pollutant reductions need to be independently verified using a method that suits local or regional conditions. So the data needs to be robust and transferable. We need to be able to apply the data from the test site to the local case where we're using it. The data needs to be peer-reviewed and published, or there needs to be some sort of separate sampling protocol, or the data needs to be completely third-party. It's one of the two. There needs to be a disassociation from the manufacturer to show some independence and rigour in the data. We also need to transfer all these results, need to look at different climate conditions, so different rainfall intensities, particle size distributions for our sediments when we look at them, mean influent and mean effluent concentrations as well. We all know what the mean concentrations of our catchments here in Brisbane are. We're somewhere around that for nitrogen, say 2 to 2.3 milligrams a litre. If we test at a super high concentration, we will get a high percent reduction. And that's not transferable to what we see on the ground down here. So we need to be careful about transferring this data across. We also need to look at the leachate, the potential leachate from the systems. So, they ask you to measure some base flow. Not on all sites base flow is possible. It doesn't exist. So what do? Apply your standard maintenance regime. Let the pollutant sit in your device and break down. Let the organic matter break down so you can sample that on the next storm event. So you can make an allowance for actually what's happening in the real world long term of your device. And the last point I'll talk about with this one is the data needs to be peer-reviewed, published in a scientific journal. So, effectively, it's not just an either-or checkbox. You have to prove that it meets your local and regional conditions. You have to show some sort of demonstration method with your leachate. And then you also have to go through the peer-review process again. So publish it, peer review it by another party, and then you can use the data. And this is effectively what we've done and what we've done with the guidelines. And that's why a lot of councils actually use them. So the good examples are the people who actually meet these guidelines. They meet the guidelines, they present the low base reductions, which is what we have to do, not concentration based. They also look at influent effluent concentrations, look at the different climatic conditions, and there's a demonstrated pathway for removal of the pollutants. So if you look at phosphorus or nitrogen, take nitrogen as an example, there's a demonstrated pathway for soluble nitrogen reduction in the technology that's explained if you want to capture the whole load. The bad, we see a lot of laboratory data that's being used, or piecemeal data, and again, it's not really relevant for our conditions. It gives you a benchmark and an idea, but doesn't give you the full picture. We tend to have errors in the method. The method's not disclosed. There might be grab samples. Might be, again, as I said, high influent concentrations. Or we just can't explain how we got the results and we don't even talk about it, which is not what we should be doing. We need to justify what we've achieved in the field by some scientific method. So we can develop. So where to from here? We need a testing protocol, definitely. Select a site, develop a project plan, get a peer reviewer involved to look at the site, independently assess the site, the data, the method, get them to look at the equipment, set up your sampling criteria, make sure that's independent of the manufacturer, peer review the report, all the storm data, get all the stakeholders involved within the process, and then finally go through this peer review process as a second alternate to the study. So in closing, look, we're here for good environmental outcomes. We're here to look after and protect the environment. The fact is, at the moment, we don't have a testing protocol, but we use these music modelling guidelines as an assessment tool. And they can form the basis, a really good basis for what needs to be an Australian testing protocol. We need the evaluation protocol and a program administrator, those two things, to make this whole system work. And why are we doing this at the end of the day? It's to provide clarity to the industry. The environment's in no hurry to get it wrong. We effectively are looking at good science, good outcomes, and good things for the environment.
Thank you, Michael. Thank you very much, Michael. After each of the presenters, we have a couple of minutes just for questions. So I encourage anyone from the audience to ask a question. And I have a roaming microphone. If you haven't got a big bad voice, you can, in theory, turn this on. And so does anyone have a question? Anyone on? Crowd. Yeah. If you do have a question, I just ask you to speak into the microphone clearly and just say where you are from and your name.
Alan Hogan, Waitana. Mike, just wondering if you could comment on local conditions. That's one of the things you pointed out in the water by design guidelines. And a lot of people may comment that your testing has been done up in North Queensland. How do you interpret that and how significant do you think that is?
Yeah, look, as we said, the data needs to be robust and transferable. And you need to look at the climate data. So you don't want to really test in areas where there's low intensity rainfall, especially here in Queensland. So if you're testing in a more high intensity rainfall situation, you're going to be more conservative with your results. That's the first point. The second point, the real big point, is the concentration of pollutants. You want to make sure that is, and especially if you look at, say, for TP or TN, it's about 0.5 milligrams litre and 2.3 milligrams litre respectively. They're your maximums you want to use for testing. So as long as your concentrations you test with your field reports are below that, you should be able to transfer that data to different regions. If you've got really high concentrations, as you know, you're going to get really high percent reductions. That's not typical of what we see in our catchments here, and the device won't perform, or the results won't be transferable across to the different regions. So we've looked at climatic conditions and also concentrations and also particle size distributions as well. So all these things need to line up individually with what our assumptions are here in southeast Queensland. And if you're more conservative, well then what does that mean? Your numbers are on the low side. Is that really a big deal?
Thank you, Michael. Any other question at all for Michael? After morning tea, we'll have the before morning tea will be about presenters mainly with the opportunity for 2 minutes of discussion, questions, etc. But after the break, we're going to have a far greater opportunity for all questions. So if you have something burning and you just get a chance to ask, there's going to be opportunities after the break. So no more questions or for Michael business to do for the time being?
Where did you get his haircut?
I went to Brad's hairdressing yesterday.
I'll put you in touch with my man, Right, thank you all very much for Michael's presentation. Thank you.